Hello. So today we'll try to learn about what is transfer learning. So let us try to understand. So I hope you people, those who are watching my video, are well aware of what is supervised and unsupervised learning model. So basically, transfer learning are used in supervised paradigm of the machine learning. Um, the whole demo of machine learning, the supervised learning paradigm, the transfer learning is basically used. So let us consider I have a data set, capital X. Okay, this capital X is basically consist of n number of samples. That means n number of samples, and each sample has a the number of features are m. Okay, that means each sample is consisting of m number of features. So if I will would like to see the data set, so it's something like 1 2 3 up to m. Okay, and here each index is basically the each of the samples. So let's say it is a capital X is basically representing the whole data set, a small x is representing the first instance, second instance, such on such way the all the instances. Okay, so x 1 2 3 up to let's say x of m. So x 1 is the first feature of the first sample, x 1 sorry 2 1 is the second feature of the first sample, and so on up to x m 1, and for the last one it is x m m it is n number of samples are there, so n. Okay, now the thing is I want to split the dataset first such a way that the last one is basically having the what the levels, corresponding levels. So in the supervised learning we have already we have already studied that x is basically represent the data set, and the corresponding label is we usually in conventional way we usually represent with y. So let us consider this is nothing but the y. Okay, so what we will do, I will split it from n cross m minus 1. Okay, so I have now m minus 1 features, and that this one the mth feature is basically represent the y. So now you can say this y is nothing but n cross 1. This is basically a vector. Okay, and this is the dimension of now the remaining x is capital X is this. Okay, now I will train the model such a way that f is the model. Okay, we are training this neural network model. So given some x, now fx will give us the y. This is the level, corresponding level of the dataset. So initially it will give some predicted level, and then we have the actual level. We'll try to find out the error y actual minus y predicted, and then using backpropagation we'll train the model. So weights will be learned, and then we can use that. I mean, we can use these weights and the model structure for a new problem. Okay, so what it basically does is in terms of probability, if you try to understand, it is giving us the probability of y, this level given some features or some data set x, that is the samples. Now once this model will get trained with some good accuracy, so let us consider we have a similar kind of problem domain. As for example, we have a problem domain initially to distinguish between red and yellow balls. Okay, so let us consider that the red balls are 1 and the yellow balls are 0. Okay, this is nothing but the y. Okay, labels, and these are features. Now given x, the ball, I want to predict the the level, corresponding level. So as because the main objective is to distinguish between the colors, so the model will try to understand what the color distribution, and it will give us the corresponding y. Okay, so once we will train, let's say we have the total size of the data set is 100,000. So in that case what we will do, it will take a lot of time to train the model. Okay, so after that we will give a good accuracy. So once the model will train, so that trained model we can use for a similar kind of problem. Let's for example, we have to distinguish now between red triangles and yellow triangle in a similar manner. sorry. So we have this red and yellow triangle over here. Now also here 1 and 0. Now if you want to distinguish between these red and yellow triangles, we can use this pre-trained model. Okay, we can directly use this pre-trained model. You can again retrain with this data set, or we can directly use and find out what is the accuracy of the model for this data set. Okay, the same f we can use, but this x will be the new data set or the new geometrical shapes of red triangle and yellow triangle, and then we see what is the y it is giving. You can also compile and retrain the model with the previous weights. Okay, so that is what the transfer learning is. This is what exactly transfer learning is. It is something like transferring the knowledge of some pre-trained model to some new problem domain. Okay, so let us go to the uh, Python implementation. So for the Python implementation, you can use any of the notebooks. So I have here the PyCharm, then Jupyter Notebook, then Spider, anything we can use. So I'll be using a Jupyter Notebook for the Python implementation. So I'll be implementing in my remote Ubuntu system. Let me log into it. Okay, let me full screen. Okay, let me open the Jupyter Notebook over here. Okay, let me go to the Python, the folder that I have created for today's video. Python 3 I will implement it. So initially we will have to find, we have to download the some CSV file or some data set. So I will be using CSV file format. The diabetic.csv file from Kaggle. Let me download it first. Okay, extract it in my folder. Okay, so you can see the CSV file over here. So let me start implementing the code. Okay. So initially you have to import some Python library such that we can read the CSV file. Okay. Sorry. So pandas is one of the Python library that we can use for reading the CSV file. Okay, so to read the CSV file and store the whole CSV file in a data frame, so you can use the pandas. So let me read the file, and let's say the name we can name the variable, let's say the data set. Okay, so read CSV will read the CSV file for us, and let me see what is the name of the CSV file. Okay, let me copy it. Okay, so just let me see the dataset. Okay, spelling mistake, sorry for that. So here you can see the dataset. So exactly the way I have mentioned that it is consisting of, let's say, some n number of samples. So here the n is nothing but 768. N columns is the number of columns here is m, where 1, the last one, is nothing but the levels. So basically we will consider m minus 1 this columns, that is the features, and the last one we will consider as the levels. Okay, so now if you want to see the shape function, basically gives us the total size of the data set, and using the type function we can get what is the type of the variable. So it is basically nothing but pandas data frame. So let me read the first m minus 1 features. So x is nothing but my data set, I mean the features. Okay, so what will you have to do? So data set is there, we have the complete data set. Next I have to go to the only, let's say, 20 to 30 features I'll read. So let's say 25. So 0 to 25 features I will read, and of the features up to I mean 0 to 25 samples I will read, and for the features 0 to 8, isn't it? Okay. So 0 to 7, basically 8 means 0 to 8 minus 1, 7. So 7 means basically total 8 features will read here. 8. So just look at here what X is giving us. Exactly, it has discarded the last one. It's the levels. Okay. So now if you see the type of X, you will find that is nothing but the data. Okay. It is nothing but pandas data frame, but I want to convert it into the numpy array. Only the values will be there, only the values. Okay, so look, it is numpy array, and next is the only the values over here. So X is basically the containing the data set, I mean the features of the data set. Now I want to get the levels. Okay, now Y for all the 25 samples I want to just the corresponding levels. So look what Y is giving us is a number here, and Y should give us the small capital Y. Okay, all the levels. Now I will create a model, the neural network model, and then we'll train the model and save the model. Then again for another problem we'll create a model, new model with the pre-trained weights. Okay. Okay, so let me give some heading over here. Model, let's say creating new model. So create model. Okay. So for that purpose I want the deep learning framework, the Python deep learning framework TensorFlow. Okay, so let's import the TensorFlow. Next I'll use the Keras framework to import the sequential model, the dense layers and activity function. For all these things I will use the Keras. Okay, so from TensorFlow dot Keras dot models import sequential. Let me copy paste this part. So it will be layers. I want to import the dense layers. Okay, let me create the model now. So model is equal to sequential next. Sorry. Let me reconnect it. Okay. Next, let's come to the first layer, first dense layer. So we'll use, let's say, 20-30 neurons more than the input dimension. So let's say 32. The input dimension is total number of features at 8, and the activation function, let's say I'm using a ReLU. Next, the next layer, okay. So here you do not require any input dimension, just the activation function. That's why I'm using the ReLU activation function only. And this is the last layer. You can use more hidden layers using only the one single hidden layer, the one input layer, one in between one dense layer, and the last one. So use dense. So one in your activation function. As because it is a binary classification, sigmod will be used. Okay, training is this model construction is done. So you can use model summary to see to see the construction of the model. So here you can see the number of parameters. So it basically means the number of input features multiplied with the neurons of the dense layer, is 32, 8 into 32 plus all the biases, that means plus 32. So it will give us the first in the first dense layer what is the number of parameters, and this way you can multiply the number of neurons in the last this present layer, the next layer, and all the biases of the next layer, then you will get the parameters, number of parameters. So totally number of parameters is 33. Next, compile the model. For the compilation we need the loss function initially. So it is because it is a binary classification, let's use binary cross entropy and the optimizer. SGT you can use, let's use SGT. Okay, and next model fitting. X is the dataset, consisting of all the features. Y is the level. Next comes the epochs, number of epochs. So I'll be using a very small number of epochs. Usually we take thousands, 10,000, 100,000 of epochs. It takes sometime, for my case it takes around 7 to 8 days, because I'm working on speech. So for higher dimensional image, for speech data, for video data, it takes a lot of time. So as you can see, CSV file, it would have taken hardly some hours, but let's just use some small number of epochs. It's a 30. I can use the batch size. Sorry. BATCH. Okay, it started training the model. So once the model training is done, we can save the model. Let's give a name. Let's x dot in h5 format, HD f5 format you can store the model. So h5. So once the model has been saved, you can get the model over here. Okay, it is saved here. Now I want to save the model in some JSON file, the whole construction, the model that I have created. Okay, so for that purpose I need, first of all I want to create in so we need the JSON file format and JavaScript object notation file format. So if you want to read about JSON file format, so you can Google it and you can read more about the JSON file format. So for storing different data structure, we can for data format we can use the JSON file format. So what it will store is wait, let me log in. What it will store is all the informations about the model that I have created. Okay, so I'll show you how you can see the JSON file and all the information of the model. So initially what I have to do is I have to get a copy of the model. Copy model. Okay, model to JSON. So it will create in JSON file format it will store it in the copy model. Okay, let me check the type. Copy, okay, this is string. So let me create a new JSON file. Okay, give some name, xyz dot json. Okay, give so we'll be writing, so w write permission is have to give as file. Okay, now file dot write, it will write the whole I mean we can write the json copy model, the json file format of the model into the newly created xyz json. So that is copy model. Let me copy it. Okay, run. So we'll get the json file over here. You can open it, text editor. Let me see. Okay, so here you can see it has all the information regarding the model. It is a sequential model, then the base size and all the where I have not used any I have not passed any argument, so it is showing null, and wherever I have used the argument is the number of the activation functions, the number of hidden layers, let's say 32 initially, then 16, all information it is showing. So activation function relu I have used, where I have not used any, so it is just giving as a null. Now these two, so try to understand what transfer learning basically means. I have to save the model and the weights, and for another problem, if the domain is problem domain is similar, then I can use the structure of the model, JSON model, or the weights. Basically, do not directly import the structure, is rather we just import the weights of the model. Okay, and we can what we can do, we can for some new problem domain you can use it. Okay, we can also compile the model. We can use a different hyperparameter during the compilation, new compilation. Okay, so let us create new model, but this model the model that I want to create, I want the model should be the exact replica of the model that I have just used. Okay, I don't want to create another model. Instead, one model I want to create, and I want to store the JSON file format such that the same model, the replica of the model, can be stored, or I can get it in a new model, and then I will store the weight files, the h5 files, all the weights, and we can reuse it. Okay, so transfer learning basically means in the deep learning model we have different deep learning models like VGD16, ResNet, TensorNet, GoogleNet, and all. So these models has been trained with thousands and thousands of images for hours. Okay, so instead of again retain the model for new data set, okay, what we can do is that the weights of the model, the weight for the h5 file of the models are available, so we can directly use the h5 file format. We can do some changes to the initial layers, that's because the data set size, the shape of the data set maybe is different in our case, or it varies from problem to problem, so we have to just make it compatible with our new data set, and in the last layer, in dense layer, we can do some changes, but rest of the part we can directly adopt the weight matrix, or the format, the exact structure of the let's say VGG16, the ResNet model, or the GoogleNet model, any deep learning model. So that is what exactly transfer learning is. So let us try to understand what I am exactly saying. So okay, so what I want is, okay, I want to read the model here, this stored model. Okay, the JSON file. Okay, give the read permission as file. Okay, and give a name, new model. Oh, sorry, it is file dot read. Okay, okay, now type of new model. So now it is also storing the string, because it is showing string is showing because it is it has stored all the values or the structure of the model, and it is in a string format. Okay, that is this one. Okay, this whole information of the model. Now I want to store the weight. Okay, before that I have to convert this JSON to again model. So initially I have converted the model to JSON and JSON to model. For that purpose I have to import one TensorFlow library. Okay, from Keras, from TensorFlow dot Keras dot models, import model from JSON 10 SOR TensorFlow models. Okay, new model. So let me convert it into the Keras model from JSON. Same one. Okay, done. Now see type of this model. This TensorFlow model. I mean, it is in Keras TensorFlow the format. Now I can use this new model and I can directly use for prediction. This is the same data I am using. I mean, those which I have used for training. This action. So you can see the prediction is in the probability. In terms of probability, we are getting the values. So more accurately, I mean, with the more epochs, we'll train the models. We make the model this model and more accurate. Okay, and more accuracy will get. So once the accuracy will be very high, then in that case you will, if you directly use, and you can give you very good accuracy. However, you have trained the model for only 30 epochs, so we cannot expect very good accuracy from this. But anyways, so the main objective was to show you how the transfer learning, I mean all the basic concept of transfer learning. So what I wanted to say that this model can be also trained. I mean, I can train the new model also. I mean, I can use new hyperparameters for compiling the model. Okay, I can use new hyperparameters, as because it is a binary classification, so loss function, it's better to use binary cross entropy. But okay, activation function, okay, optimizer, let me check. Change optimizer, let me change. Earlier was stochastic gradient descent, let me, this time it is I'm using as Adam optimizer. So okay, let me fit, okay, this model, new model, fit using the same data set, let's say. Okay, so what I was saying that if the problem domain is similar for the both, I mean the both data set is similar. Okay, so the red color ball and the yellow color ball problem that I have shown, so let us consider the same data, I mean to the format of the data set, the type of the problem is almost similar. Let's say now I have to initially works for red ball and yellow ball. Now I need to classify between the red triangles and the yellow triangles. In that case, transfer learning are used. Okay, but in this case I am not again using some other data set, rather I am using the same data set just to show you the what exactly the concept of transfer learning is. Okay, we can use some new data set. I mean, if the same type of features are there, let's say if the diabetes patient, I mean for the same, let's say the diabetes patient, but some other values are also, I mean on some other um, features also, the classification has been made. Okay, here the whatever features has been considered, let's say with this feature some additional one or two features has been added, and the binary classification is done. So you can use and you can see whether it is working for your case or I mean or not. Okay, not necessarily always the transfer learning gives us the very good accuracy, but yes, it varies from problem to problem. Okay, So instead of using another data set, I am just using the same x and y. Okay, number of epochs I am, let's say this time, increasing 50. Okay, epochs. For 50 number of epochs I have trained, and then model, new model dot predict. I can use again x. It will give us the accurate, I mean the probability. In terms of probability, it is giving what should be the outcome, I mean the levels of each of the 25 data sets. Okay, the first one is 0.98. It seems it is more closer to 1. That means it belongs to 1. It has the type, the patient has the diabetes. A similar way, depending on these values, we can understand the in terms of probability. Then whether if it is very, I mean, if usually what happens, the same like the floor and seal concept. So if it is more than 0.5, we can, or it is more closer to 1, let's say 0.9, 0.87, something like that, means it is very much similar to that of the one class. I mean the in the binary, if it we are dealing with the binary class, and if it is more closer to 0, then we can say that it belongs to the zeroth class. Okay, we can also use some other activation function, like if the accuracy more than, let's say, this and that, then it belongs to class 1, and if less than that, it belongs to that class. Okay, so usually sigmoid function is used. The logistic regression model is a different kind of model. So usually we use the logistic regression model, so we can give some threshold, specific threshold. After, if the outcome is more than that, we can say that it belongs to the class 1, and if it is less than that, so similar strategy you can also use here. Anyways, these values are basically meaning that 0.98 basically means that it belongs to the 0.98 basically means a 98% confidence. Okay, the accuracy is 0.998 for the first class, means it 98% similar to that of the belongs to the class 1 level. So these way you can understand, but what I am saying that it can be more understandable if you use the logistic regression. Using the logistic regression concept, we can very easily understand that if it is more than some threshold, then directly belongs to the class 1 binary classification. Anyways, the main objective of the students' videos was to uh, make you familiar to the what transfer learning, what exactly the concept of transfer learning is, and how you can use. So here I have used in my own model. I create the model, I train the model, stored the model and the weights, and again reuse the model. So in the transfer learning concept, what exactly basically use are already pre-trained good models. So all the deep learning, well-known state-of-the-art deep learning models, ResNet, BGGNet, all these deep learning models are use their weights and their structure. And the whole network structure is used, and instead of again recreate the model. Okay, we can just make it compatible with our data set, and we can adopt the previously trained model, and this is how uh, we can manage our time. Otherwise it will take a lot of time to train a model again from the beginning with a huge data set. So that is the concept of transfer learning, just transferring the knowledge of one model to another. And what I have already said, that it do not give us a guarantee that always will give a it will give a good accuracy. Okay, you have to do some tuning maybe. Okay, thank you.